So let's start with broadcasting now. सबसे पहले we have to import the numpy as np, right? And create a 4x3 matrix using np.zeros and print it. Okay. After doing this, create a one-dimensional array with values 1, 0, and 2, and we call it add_rows. Do both these things very quickly. Done? Now tell me, if I have to add these two matrices, how will they add? If I had to add a 4x3 to a 3x1 matrix, how I can add these two? Means क्या output आएगा?
First row will get added, and then rest of the things would be same as that of the first matrix. मतलब zero ही रहेंगे.
No. See this. So now we have ये एक matrix है हमारा, right? And then I'm adding 1, 0, 2, right? So this is 4x4. This is 4x3. 4x3 here, and this is 3x1,
1
right?
cross 3. 1
1x3.
cross
So
3.
sorry, yes. 3 row 3 column, right? तो अब अगर मुझे इस दोनों का ऐड करना है तो क्या होगा? This thing will be extended like this, so that also becomes 4x3. एंड अब इसका एलिमेंट वाइज एडिशन कर दूंगा मैं. तो क्या हो जाएगा? 102, 102, 102 and 102. So this is known as broadcasting. इसको मैंने इस एक्सिस के अलाउंग ब्रॉडकास्ट कर दिया, राइट? एक एग्जांपल और देखते हैं. 1 2 3 प्लस 3 2 1. क्या आएगा इसका आउटपुट? ये आपका 3x1, ये है आपका 1x3.
Answer would be 4 4 4. 4 4 4 का 3 by 3 मैट्रिक्स।
फिर से बोलो, 4 4 4 का
3 by 3 मैट्रिक्स।
कैसे किया आपने बताइए?
This 1 2 3 will get broadcasted to make 3 columns. So first matrix would be 1 2 3 1 2 3 1 2 3 like this,
इसका
और इसका 3 2 1 3 2 1 3 2 1।
अब इसका
अब
ऐड
ऐड
करोगे तो
करेंगे
क्या
तो
है?
4 4 4 4 4 4।
कैसे 4 4 4
नहीं
क्यों
नहीं
बोल रहे
नहीं,
हो?
एक मिनट।
हाँ,
हाँ,
4 3 2।
4 no 4 3 2, again 4 5 4 3 6 5 आणि 4
ये आ जाएगा देखो,
4 4 6 5 4।
सॉरी 4 है ये, हाँ बस ठीक है। सो ये ब्रॉडकास्टिंग तभी हो सकता है जब एटलीस्ट दो में से एक डायमेंशन आपका कॉमन हो। हमेशा नहीं हो सकता ये। मीन सपोज इफ आई हैव अ 2 x 2 मैट्रिक्स 1 2 3 4, और अगर ये करना हो मेरे को 3 2 1, तो आई कैन नॉट डू दिस। ये 2 x 2 है, ये 1 x 3 है, तो ये नहीं हो पाएगा, ये एरर दे देगा आपको। ठीक है, सो दिस इज नोन एज ब्रॉडकास्टिंग। एक दो एग्जांपल और देखते हैं कि समझ में आया आपको।
यस।
ओके, सो इसका थंब रूल यही है कि जस्ट मेक श्योर वन डायमेंशन शुड बी एटलीस्ट कॉमन, तभी हो पाएगा, अदरवाइज इट वोंट बी पॉसिबल। राइट, लेट्स डू फ्यू मोर एग्जांपल्स। सो ये पहले ये कर लो। नाउ इफ आई ऐड दिस टू, आई विल गेट दिस 102 102 102 102। okay, now after this create a column vector which has value 0 1 2 3. So it's a 4 x 1 column vector. Do this. Just a second. If I...
सर आप कहीं खूब ठक 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 आवाज आ रहा है बहुत, मतलब आपका टाइपिंग इको हो रहा है क्या?
नहीं, इको नहीं हो रहा है। आवाज आ रहा है आपको कुछ?
खड़ खड़ खड़, हाँ बहुत खड़ खड़, बहुत ही डिस्टर्बेंस आ रहा है।
एक सेकंड समीर, एक बार आप म्यूट होना। अब ठीक है क्या?
हाँ अभी नहीं आ रहा है ऐसा, मतलब बहुत ऐसा लग रहा है खड़ 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 खड़।
ओके, अब ठीक है ना?
हाँ अभी अभी क्लियर है।
ठीक है। नाउ क्रिएट अ 4 x 1। कैसे बनाएंगे? एक उसको ट्रांसपोज लेंगे, विल गेट लाइक दिस। So this dot t is a transpose. हुआ ये? So now I create first. This was a row vector. It was 1 cross 4. इसको मैंने using this dot t I can take a transpose of any matrix. Right? Transpose means shifting, inverting rows to columns and columns to rows. Okay. Now I want to add this add underscore columns to my this y. So what will be the output? Without doing it, Pravakar.
So it will be sir 4 cross 1 matrix, no sir? Because it transpose, right?
So this is 0, 1, 2, 3, right? Now I'm asking what is the output of the addition?
Okay. Which line you are talking? Line 5 or 9?
5 means y plus इन दोनों को add करना है, y plus add calls.
So this 4 cross 1 will be extended to 0 0 0 1 1 1 1 1. Sorry, 0 1 2 3 again 0 1 2
2,
3
3
and
and
0
0,
1
1, 2, 3, right? It will be replicated 3 times, right?
Yeah. So it will become 3 cross 3 matrix. Right?
4 cross 3.
Oh, sorry, yeah, 4 cross 3.
Okay,
Go
and
ahead
then it
and
will
see.
be added, right? So what will be the
Yes.
output? Let's see that. So simply the first row will become 1, then it will be 2, then 3, then 4. Right? 1, 2, 3, 4. Second row will be simply 0, 1, 2, 3. Third row will be 2, 3, 4, 5. Let's do this. I think this is not.
It's correct, sir. If we have taken start plus add cost, it would be y plus add cost, and we will get the same.
Achha, okay, star plus add calls. Okay, I've done y plus add calls. So sorry. Start is a zero matrix, right? Okay.
Uh,
Yes, yes, yes.
Mhm.
Okay, do this quickly. Now let's say, suppose if I have to add a scalar, let's say 2. Now in that case, what will happen?
So this, so it will not add because dimension is not same, na?
Right, but if it is a scalar, it can be it will be added to each and every value.
So,
It
but
will be
you
like
only told
this.
us that one of
Right,
the dimensions should be same.
right, but that's not true for the case of scalars.
Okay, so it will be added
Added,
to,
right?
I mean, depending on the arithmetic operation, right?
Right, if it is multiplication, it will multiply with all the values.
Okay.
Okay. I think one more thing, let me see. I think if it is multiple, then also it will work. Let's try one thing. Yes, I think it will multiple also will work. So if I have a 4 cross 3 and a 2 cross 3, फिर तो वो रिप्लिकेट कर ही सकता है उसको, इसमें तो ये कॉमन हो ही जाएगा, है ना?
Mm-hmm.
बट इफ इट इज अ, हाँ राइट, दिस विल बी ट्रू ओनली फॉर स्केलर्स ओनली, कि सब जगह ऐड हो जाएगा वो. ओके.
Himanshu,
हाँ हाँ.
uh, if we define number as the elements of a list, and then we similarly, if we have two kind of list, I mean two list having elements having number as its element, we are not able to add those two lists. That's why we are using NumPy here, right?
No, that's not. See, list, NumPy is based upon list only, but NumPy
Mm-hmm.
has, see, list has been restricted in a certain way. So first of all,
Okay.
NumPy cannot be heterogeneous. NumPy arrays cannot be heterogeneous. List can be heterogeneous,
Yes.
right?
Okay.
Plus,
Mm-hmm.
the way of it is much more memory and space efficient as compared to a list.
Okay.
Okay. Plus,
Mm-hmm.
Yeah, so that's why what we have done is like, so for certain mathematical operations where we require a lot of computations to do, lists can be very, very slow.
Okay.
Okay, so that's why NumPy was created out of lists only.
Okay.
Okay, so so it's now in this NumPy library there are so many mathematical operations that you can easily perform. Okay.
Yeah.
But those will not get performed on heterogeneous, no? These are for only homogeneous list.
Right, right.
For heterogeneous, we have to go for this list only.
Yeah.
And Himanshu, how do we slice this? I mean, this first list, it refers to zero row, and then similarly two brackets. I mean, first will represent zero, and like that
Yes.
only we
So it will be
slice.
0, 1, 2, 3 and 0, 1, 2.
Okay.
Okay, so start from 0 from here. So the first element will be 0,
Mhm.
comma 0 and then move on the right and the down.
Okay.
Okay.
Yeah.
Now do this quickly. Create a 3 cross 4 matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Done. And now create a array B which is 4 cross 1. And now add the 2.
Hey, Himanshu, just made join.
Yeah,
Sorry for being late.
just we started around 15 minutes back. We are doing broadcasting.
Okay. Okay.
Done.
Yeah.
Okay. So now if you add it, simply it's a, this one is a 3 cross 4. and that's a 4 cross 1, right? So now if you add it, you will get this. Good. Now let's see the comparison between ND arrays and lists. So that now we are going to set up a speed test. Okay. Now what we are going to do, we are going to calculate the sum of large number of values. So simply do one thing. So no need to see, you have already imported numpy, so no need to do this. Just declare a size. Okay. That's it. No need to declare this also. This is already in Jupyter. Okay. So now create an ND array. ऐसे नहीं बनेगा अपना np.arrange से बनेगा. Okay. Do this and do this. Right. Now let's sum all the elements of this ND array. So it says 2.78 milliseconds plus minus 200 microseconds per loop. That's the time required to compute this. So this percentage time at which we have written here is called a magic function. So any function that starts with a percentage are called magic function in Jupyter. And there are some certain inbuilt functions in Jupyter, like save, load, run, all that thing. Now let's do the same thing with the help of a list. So now create a list of the same size using the range. Right, list of range of size, and you can print the type of it. Okay, and now do the same thing using for a list. See this now. It says 42.8 millisecond plus minus 1.83 milliseconds, right? It was only 2.78 milliseconds. So they are at least 1/10 fast, not 1/10, even more than that faster than a list. So what this percentage time it does is it runs the operation multiple times so that we get a better estimate. So for this calculation, it has run it 7 runs of 10 loops each. Okay, that's why it has calculated the standard deviation along with the mean and everything. Right. Here it has run 7 runs and 100 loops each. So the time taken is less, it will run more number of times. If the time taken will be more, it will automatically adjust and run for less number of times and give you a better estimate. So percentage time will also work, but it will only run for a single loop. This will be more percentage time, it is more accurate. Okay.
Yes.
Now,
What's the
yes,
difference between time it and time?
time it will run the operation only for a single loop.
Okay.
Okay. Well, time it will run it for multiple loops. So here it is run for 10 loops. 7 runs of 10 loops each. So almost 70 times it is executed. Here it is 700 times it is executed. So that you can get a better average and better approximation.
What was that wall time?
Sorry,
Wall time.
I'm not getting you. Come again.
When you have written only time function,
Yeah.
We have executed it. We have got wall time also. What was that?
नहीं समझ में आया आपका, एक सेकंड, आप कह रहे हो कि इसमें कुछ और भी आ रहा था साथ में?
Or probably she can convey using chat.
Okay, wall time 30.1 milliseconds. I'm not sure about this. Now if
CPU time and wall time.
right. Now if I do the same thing for a, so,
Array.
yes, so this listen. nd underscore array dot sum. This is 5.11 milliseconds. But if I run it again, it might change also. See this, right? So that's why this percentage time it is better, more accurate, because there will be a lot of function like fluctuation because of your processor capabilities also, right? Means how many applications are running and etc etc. Okay.
Yeah.
So better is to use time it rather than the time. Yeah.
Time it stands for time equation.
Yes, kind of. Means you will do it multiple times.
I answered this Sunday. I lost my connection. So what I think happened was 2 minutes before.
No, we're just discussing the same thing only, like how to compute the how to, we are comparing the ND arrays with the list. Okay, means which one is more faster using the time it function.
Time it function.
Yeah. Okay.
So we realize that NDR is more efficient, more faster.
Much faster, yes. Up to order of,
Any
yes.
so is there anywhere or any application where we should use list only other than NDRA?
So when you yes, if you have any heterogeneous application, means you have to store heterogeneous data,
Okay.
then you should go for
Understood.
list. Okay. Yeah. Now you can also read and write these numpy arrays to your disk, right? So far these arrays are correct, is computed in runtime only, right? I want to save it now so that I can use it later also. So there are two ways. One, I can save it in a binary format, other is in a text format, right? So now if x is my np array like this, okay, there is a function np.save. I'm saving with an array and x is the variable that I'm saving. So it will create a binary file with the name n array, which you can see here. See this file has been created, n_array.npy, right? And now if you want to load it later on, you can simply use np.load. Right? Means I can write my np arrays to a disk also. Now if you want to do it in a text format, you can use np.save.txt. And then again the same thing. So you have to name the variable and you have to give the delimiter. So I want to keep it as comma separated. Now this we'll be able to read. So it has only two values, 23.23 and 24.24. You can see this. So this will be
So
handy. Yeah.
one question again. So every time we need to import the packages once you log in or once you
Yeah.
open our. So,
You have to import the package every time you run the file, or if you if you restart the kernel, you have to do that.
yeah.
Done?
Yeah.
Yes.
Okay. So now we know how to save a NumPy array also. Okay. Now there are certain additional common ND array operations also, which we'll have a quick look. So one is dot product on matrices and inner product on vectors. Okay. So dot product is क्या कर दिया इसने x2d dot dot np dot ts. So these are the dot products of my these two matrices. Do you know what is a dot product?
No.
No.
I think you can skip this part. It's not much required for us, so I think better to skip this. Now the major things that we can see here is sum. Sum you already know. So sum you can do XSY also. We have seen it. So I can do col sum also, and I can do row sum also. So col sum is x is equal to 0, row sum is x is equal to 1. Okay, this we have done yesterday also. So we calculated the mean yesterday, right? Mean and median. So sum is also the same way. Now let's do some element wise function. So for example, let's compare two arrays, well, array value to get the maximum of each. So create a random array x. So these are 8 normally distributed values. Then I'll just use some other seed here. Let's say 2 here. Okay. Then if you use np.maximum x comma y, it will element wise it will select the maximum values.
Okay.
Right.
Hmm.
Done?
Yes.
Now this reshaping is a very common and very useful function. Now create an 1D array from 0 to 19 using a range.
This range is a stepwise function or something.
Yes. So you can set the step also.
Which argument we have to pass?
See this.
Okay.
Okay. Start, stop, and then the step.
Okay.
Same as the range function.
Yeah, range is not. Yeah, range is for not for NumPy. For NumPy objects, you have to use np.arrange.
Okay.
Okay. Yeah. Okay. So let me go back. I just
So
make
it gives
it.
us a sequence.
It gives you a sequence.
Range gives us a sequence.
Yes. Right. एक और function and that is also a bit useful called np.linespace. Okay, so which is required if you want to create evenly spaced numbers. Say for example between 0 and 10 I want to create 20 numbers, so it will do this. Zero 0.5 से नहीं हो सकता था क्या? I think 19 will do be better. No, 21. Yes, 21 is better. Yeah. Okay, so line space can be used for equispacing. You have to generate variables at equal intervals.
Here I think so. 21 minus 1 is going to be taken. Na?
Yeah, so including 0 अगर मुझे 0 include करना है तो 21 चाहिए होगा ना. 0.51 ऐसे करना है तो 21 हो जाएगा. Both including है ये.
0.1. 0 and 10 both are including. Na?
Both are
But
inclusive.
when we are saying generally we say that if I want from 0 to 10, including
Right.
both, with 20 same intervals, वो 0.5 वगैरह आना चाहिए. But it was not coming with 20. It's 20 the result for 20.
राणा जी आपका माइक, आपकी आवाज क्लियर नहीं आ रही है, डिफिकल्ट है समझने में. तो माइक चेक करो एक बार.
Hello.
Yes.
Now it's clear. Is it clear now?
No, not that much. पहले से बेटर, थोड़ा सा बेटर है, बट आप
आपकी बात इको हो रही है.
हाँ, आप वो यूज नहीं कर, माइक यूज नहीं कर रहे क्या?
मैं कंप्यूटर का मैच यूज कर रही हूँ.
सॉरी.
I'm using the computer's mic.
नहीं, ईयरफोन वाला नहीं यूज कर रहे क्या?
नहीं, एक मिनट.
हाँ वो यूज
Let me use
करो.
it.
हाँ, इससे बहुत दिक्कत आ रहा है. हाँ.
Just a minute.
Yes, done.
Hello.
Yes.
Yes.
Now it's clear.
Yeah, much better.
So what I was saying that we are starting with 0
Right.
up to 10, and when we want 20 values with equal interval. So when we generally if we see that from 0 to 10, if we want equal intervals, then it would be 0.5, 1.5 and so on. But it was not giving me the same that result when I was giving 20 here. But when I put 21, then we are getting that result. Huh?
Right.
So is it the case that it is for 21? मतलब वो yesterday we have seen ना कि one last range -1 and +1 will not include. So when
No,
we are
okay.
putting 20, it is going.
Pranali, first thing is like वो मतलब don't ये इसमें 10 is inclusive here. Right. So now if you generate 21 values, then it will be, see now we have generated 21 values, right? इसलिए आपको वैसे आ रहा है 21 पेज आ रहा है. 20 करता हूँ तो 21 पेज मतलब 21 पेज बना सकता है, बट इट वोंट बी एट इंटरवल ऑफ 0.5, राइट?
0.5, हाँ.
तो देखोगे तो 0.51 ऐसे करेंगे तो हमारा 21 वैल्यू जनरेट हो रही है. राइट.
Okay.
एक सेकेंड. हाँ, राइट.
Himanshu, I just saw there was a pop-up of help on the line space function.
Yes, you can also have.
How did we do that? Push keyboard shortcut?
Shift tab. Within the, yeah, shift tab twice will give you a bigger window.
Shift tab twice.
Or we can.
This is help only, pop-up help.
Yes, or otherwise you can use a question mark also. np.linespace then a question mark.
वो तो.
Okay. Yes. Okay. इसमें स्टेप का नहीं होता क्या? एक सेकेंड. इसमें एक दो चीज और देख सकते हो. इसमें यू कैन रिट्रीव द स्टेप. इसको ट्रू कर देंगे तो इट विल गिव यू द व्हाट इज द स्टेप इट इज यूजिंग. So the step here is 0.01. And Pranali, you can do this also. You can, if you want to make it false, you can make the endpoint false also. So now this will change. So now it will want to go up to 100.
Yeah.
Okay.
Endpoint true से क्या हुआ?
Endpoint true default वही है, 100 include हो जाता. The last value will be included. 1.
Include हो जाएगा.
That's the default value. So endpoint true pass is not required. False करोगे तो it won't be included then. Okay. Yeah.
Default is true.
Yeah. Okay, so now let's come to reshape now. So create a one-dimensional vector from 0 to 19 using arange. Now there's a function called reshape. So now I'm giving 4, 5. So it will reshape it automatically into a 4 cross 5 matrix. And even better is you just pass 4 comma minus 1. Means if I fix one index, or the other one can be automatically calculated, right? Because we have to anyways conserve this length. So this is more handy. It means if we don't have to calculate ourselves. Like if I know I want to just use 4 rows, I can simply put 4 comma minus 1. Or if I want to just use 2 rows, I can put 2 comma minus 1, and then it will automatically make it like this. Okay. So ये -1 याद रखना. Yes, done.
Manshu?
Yeah.
Yeah. The number of elements in the matrix using this reshape function should be equal to the number of elements in the array, in that ARR that we
Yes,
created
yes,
using
yes,
arrange
yes.
function. It will not implicitly cover the value if we say,
I
for
don't.
example, if we are
No, it won't do that.
trace back.
Yes. It won't do that. It has to be of the same shape. Yeah. The length has to be conserved. Okay. Next we have transpose. Done.
Yes.
So dot t is simply for transpose. Okay. Now there is a where function also. Np dot where. So it's like our if else. So np dot where, if the condition is true, do this, else do this. So create two arrays x1 and y1. 1, 1 to 5, other is 11, 22, 33, 44, and 55. If you want, I can ping you this. Right? And then create a filter, Boolean array. True, false, true, false, true. Okay. Now what I want is, like, whenever this filter is true, I want to take value from x1. Whenever it is false, I want to take value from y1. So what we'll do is, like, we'll use np.where function and we'll simply pass filter here. So other than filter, the more common use is I pass a condition which returns a Boolean output. Right? So here automatically is a Boolean vector, so I can simply pass filter. So whenever this condition will be true, it will take x1, otherwise it will take y1. Print this now. Oh, I have not executed this. एक और example, let's do one more example. Create a 5x5 random matrix. Okay. Now what I want to do is, so this is all the values are from 0 and 1, between 0 and 1 only. It's a uniform distributed matrix. Now what I want to do is, like, anytime the value is more than 0.5 in this matrix, I will make it 1000. Anytime it is less than 0.5, I will make it -1. So this so I can easily implement it from np.fair. So whenever this condition returns a true, it will take 1000, otherwise it's -1. ये करो, फिर एक चीज और बताता हूँ.
Is there any seed function in Python?
Yes, np.random.seed. कल किया था ना हमने. np.random.seed. And then you can say 1. Yes, done.
Yes.
Now what I want to do here is, in case the value is more than 0.5 in mat, I want to make it 1000, but if it is not, I want to retain the original value. Okay. Just give me a moment. How to do that? I can simply pass, in place of -1, I can just simply pass mat. So all the values will be kept similar, same, which are the which don't meet this condition. Okay, so this is also used many times, so you need to be aware of this. Done?
Yes.
Okay. Now there is any or all conditionals also in NumPy. Okay. Let's do this now. Now create a Boolean array. Let me ping you this. Okay. Now I want to check whether there is any true value or not. So even if there is a single true or even a single condition that holds true, it will return yes. Okay. And then we have all also, which will give me false because all are not true. So it's somewhat similar to is.any and all like that.
Okay.
Yes. Yes.
Regarding the heading, we can change the size of the heading by using the hash sign.
Yes. Plus you can use HTML
And
also.
how can we change the color?
You can use HTML also. See this.
Okay. And okay.
Okay.
This is for HTML coding. Yeah.
Yeah. Done.
Yeah.
Okay. Now let's quickly see random number generation also. Now np.random.normal. Why the zero is passed? I'm not sure. Okay, let's look at the help of this. np.random.normal. So I have to pass random. Okay. Oops. कहाँ गया वो? Yes. See this now. So this LOC is actually the mean, and this is the standard deviation. It draws random sample from a normal distribution. So here you can pass the mean and standard deviation as per your requirement. Okay. Just give me a moment. Yes. Okay, so you can pass the standard deviation here and the size also here, right? So now if I'm not passing anything, the mean is taken as 0 and the standard deviation is taken as 1. Okay.
So
If
here the
yes.
okay. Yeah, understood. I thought it's a 1 and 5 are mean and standard
No,
distribution, but
this is the
basically 0
size.
and 1.
That's the
Okay.
size. So I can pass it like this also, tuple. So 0,
Yeah,
1 and this. Or if you want, you can pass 2, 1 and this. So it will be centered around 2.
we'll give the normal distribution.
Yeah, that's a normal distribution, right? Yeah, done.
Yes.
Now I can also pass I can also generate random integers using np.random.randint. Right? So now low, high, and the size. So how much I want to generate? I believe I can pass a tuple also to generate a matrix. Yes, you can do that. Okay. Now if I want to let's go back. Let's make it 4 only. Now if I want to uh, mutate it, means I want to change the position of it, so I can simply use permutation also. np.random.permutation of z. It will shuffle this. So if I
What is
keep on
this
running
low
it,
and high? What is this low and high here?
so what is the start and end point between which you want to generate? So I want to generate between 2 and 50 only. Okay, with the size of 4. So 4 numbers will be generated.
And is there a concept of seed also in this?
Yes, and np.random.seed.
Okay, fine.
Okay. Now if you want to generate a uniform distribution, you can simply use np.random.uniform. Right. So this we have already seen normal. Okay. Now let's see how we can merge two data sets. So create two random data sets with all random numbers. One is of size, both of size 2, 2, between 2 and 50, and call them K and M. Done. Now we can stack them horizontally and we can stack them vertically as well. Okay. Now if you want to stack them vertically, you can use the V stack K and M. So it will be stacked. It's like row bind, you can simply say. And a horizontal stack is like your C bind. But that will work on NP arrays only. Okay. So np.vstack, np.hstack, or simply np.concatenate, which you can use both. X is equal to 0 will be for rows. Okay. X is equal to 1 will be for columns. So you have taken the transpose of M and joined that.
So this is same as R bind, C bind in R.
Yes, but this won't work on data frame. This will work only for NP arrays only.
Himanshu?
Yes.
Uh, okay, so this, I mean, this edge stack will work column wise, right?
Yes.
Sorry, row wise. No, sorry, column wise, right?
Yes.
Okay.
H stack is column bind. V stack is vertical. So this is
Okay.
horizontal stack. This is vertical stack. Yeah.
By mistake, actually, I use only stack, so it created another dimension only. I mean, by mistake, I use only
Okay.
stack function.
So it will create a
Uh,
3-dimension.
I
Let
mean,
me
it added one more dimension to that. Yeah.
check that. K comma M. Right. No, it's not. Okay, sorry. I have to pass it like this.
Yeah. Double bracket, right?
Tuple. Yes. So if you look at the shape of it,
Dot shape.
it's 3D now.
Okay.
Okay, so it's like एक के पीछे stack कर दिया, one after the other. It's not
Okay.
in the same plane,
Hmm.
right?
It has one more dimension has been added into that,
Exactly,
right?
exactly, yes. Okay, good. Yeah, do this till concatenate. Just give me a moment. Yes, done. Okay. So now we have done with the basics of NumPy. So we have covered more or less, it's not all the functions, but yes, most of the common functions we have covered. Now we start with the case study now in NumPy to get more practice on it. Okay.
Yes.
So let me open this. Oops. It's taking some time to start. Meanwhile, let me start from the HTML file. Yes. Now we are going to do satellite image data analysis using NumPy. क्यों ये लोड क्यों नहीं हो रहा ये? Yeah, now this is loaded. Okay, leave it. Yeah. Okay. Now I'll just quickly go through the case. So it says Wi-Fi is an integrated system for wildfire analysis with specific regard to changing urban dynamics and climate. The system integrates networked observations such as heterogeneous satellite data and real-time remote sensor data with computational techniques in signal processing, visualization, modeling, and data assimilation to provide a scalable method to monitor such phenomena as weather patterns that can help predict a wildfire's rate of spread. In this example, we'll analyze a sample satellite image dataset from Wi-Fi using the NumPy library. So the first thing you have to do is you have to load required libraries. So first is import NumPy as NP. From SciPy, I just want to load one method, that is miscellaneous. So just load this, and then load in from matplotlib.pyplot, which we'll see later on. Load PLT. Sorry, import matplotlib.pyplot as PLT.
Himanshu, can we get the data set?
Sorry, the dataset
There must be
is an image. You have to download it. So how will you download it? Make sure you're downloading it on your Azure, not on your local system.
Yes.
Okay.
This is an image, right?
Yes. So what are images? See this. Okay. So how to download the image now? Look at this. Put an exclamatory. Now it's a shell script. wget, and then simply paste the link and then execute it. See this. It will download in 8. It's almost 8 MB. तो ये फाइल अब डाउनलोड हो चुकी है आपके Azure में. Now any command which I run with an exclamatory is a shell script, not a Python.
So just scroll your screen upward. एक मिनट हाँ.
भेज देंगे क्या जो साइफाई जो लिखे हैं वो टेक्स्ट
ये चारों चीजें
चैट में. हाँ ये चलो.
Now this first command, this matplotlib percentage matplotlib inline is for plotting. It is to show our plots within the Jupyter notebook only. Yes, ये डाउनलोड किया सब लोगों ने?
Yes.
Now I'll just change this. Now I'll be using that some miscellaneous function from the SciPy. Oh, ये क्या हो गया? Okay. So mic.imread. Imread is for image reading. And what was the name of my file? It was hd 3layers.jpg. Okay. And now execute this. Error is there. The miscellaneous is not defined. I have not executed this. Sorry. Image download कर ली सब लोगों ने? And now read it using this photo underscore data, and then execute the type of it. So this is a Numpy array. First of all, let me show you the image by plotting it within Jupyter Notebook. So plot.figure, then fixed size is an argument that parameter I'm passing here as 15,15. It will restrict the size of the image. कितना आपका इसको यहाँ पे जगह घेरना चाहिए. And then plt.im show photo data. And now you can see this figure.
Hello.
Yes, Pranali.
Sir, sorry, will you please repeat what we have done? Actually, I have not there. I lost my connection. I have imported those files. Matplotlib हो गया. I have downloaded the database also.
So this is a JPG file that we have downloaded, right?
Now, that is over.
Now read the file and save it in photo underscore data. So this is using the mic.imread function.
But even so, in my case, it's not reading the file. This photo underscore hd3layers.jpg file.
What is the error?
Not giving any error on it.
Sorry?
The star mark. It's not giving any error. It's giving some star mark.
So star mark means it is still executing. Do one thing, that restart the kernel once. इसको press कर दो एक बार.
Okay. Now it's working. It's got it now.
Okay, it might take some time. It's a big file, 8 MB file.
Yes. Then we need to plot also.
Now I want to show this. Look at this image. So now this is for any, if you want to use any of your own image, so you can say any JPG file can be read in this way, and you can plot it also over here.
So scroll up. Let's सर ये फाइल जो हमने इंपोर्ट करी है ये एक बार एक्सप्लेन कीजिए ना।
ये हमारी एक जेपीजी फाइल है, एक इमेज है, राइट?
हाँ।
So image is what? Image is nothing but numbers only, right? Color pixels होते हैं उसमें,
हाँ।
right? So now it's actually an ND array only. Image is simply an ND array, n-dimensional array, right? So I'll show you. So उसको मैंने import कर लिया है using this function misc.imread. And now if you look at the type, it's a numpy ND array, जैसे हम अभी तक arrays बना रहे थे, right?
Okay.
Now I want to work on this. Now if you want, I can plot it also. So plt.figure. Fixed size is for selecting the size of how much I want to display. So if you make it 10, 10, वो थोड़ा छोटा डिस्प्ले होगा। ये सब हम मैटप्लॉटलिब में सीखेंगे आगे जाके।
Fine.
Okay. So now I am displaying the plt.im show is to show the image. ये image अब आ गया आपका, right? Now if I now so photo underscore data is numpy here, so all the function that we have studied will work upon it. Okay, now look at the shape of it. So it's 3725, 4797, 3. Right. So I have 3725 rows, 4797 columns, and 3 dimensions. What are these 3 dimensions? These 3 dimensions are for my RGB colors. एक layer R की होगी, एक G की होगी, एक B की होगी. Right? If you want, I can show you some of the. ऐसा पूरा print करोगे तो समझ में नहीं आएगा. But what you can do is photo underscore data, इसको सबसेट करके आप प्रिंट कर सकते हो. First row, first column, and this.
Himanshu.
Yes.
What does these numbers signify? 3 numbers.
Okay, these are my
RGB
shape. Number of rows, number of columns, and 3 dimensions.
3 dimension. What is the third dimension? Okay.
Is the colors, RGB layers.
Okay.
If you see here, it's a 2D over here, right? So these are the rows and columns that we have, right?
Yes.
And then since it's a color image, so it will have 3 channels: red channel, green channel, and blue channel. And that is actually saved in 3 dimensions, right? 1 to 3 layers. That's why it is 3.
Okay. And I think in most of the cases it would be 3 only because these are the 3 primary colors.
Exactly. Most of the images will be saved like this only.
Okay.
Okay.
Yeah.
Now, what is the meaning of this? Look at 9th.
First row, first column, and
so basically for the first row and first
row, first column, R value.
Not R value, all the 3 values, RGB values. If I make it 0, now this is the R value.
And if you don't put anything, then also it means all the values?
No, it will throw an error. Okay, if you don't put in comma, then it is all the values.
So like comma and not any.
Comma will error आएगा. It's not like error नहीं आ रहा इसमें. It throws an error usually.
Comma is all 3 dimensions.
Yeah. So now these are the RGB.
Okay.
Yeah, these are my RGB values now for that particular matrix cell, which is at 0,0 position.
एक बार दोबारा बताना.
Okay. See this. So now this is my 0. So this point over here, somewhere here, in this corner. So these are my pixels, right? So this corner, look at this corner, anyways looks like blue only. There is no red here. So that's the colors in this top left corner. right? Let's say this, let's look here, this is all black, right? So let's see this. This is my row. Let's say I take a rows from only that's 3000. Column is 0 and then this column. It's 2, 0 and 1. So all 0 means black. Right? So here all these are very close to 0 only. 2, 0 and 1. So that's my this black color. And if you want I can use some more rows. 3002. 2 rows and let's say 2 columns. Sorry. So these are my. So now I am using 4 pixels, right? It's 2 cross 2. So I have these 4 color RGB for these 4 pixels. It's all same. This all black area. Now explore this area. This looks red, right? So you should have a high value of red. Okay, one more thing. The values of color vary from 0 to 255.
Yes.
If it is a 8-bit image, right? 0 to 255. So now they should have a high value of red here, right? So let's look at the position here. Its rows are 2000. Column will be somewhere 3100 or something, right?
115
ये ले लेते हैं, ये ज़्यादा better. 2500 और 3200 के आसपास. See this, R is 172 now. Means it's more towards red now. ये clear है सबको? So now are you getting how how we have this data?
Yep.
Means if you want to, let me show you on this OneNote also. So I have this matrix. Okay, which is 3725 in rows, 4797 in columns, and then I have these 3 layers of it. Right? It's like this. One layer R, G, and B. There's the third dimension. Right? Okay.
Yep.
Yes, now see this. Now it says the shape of the ND array shows that it is a 3-layered matrix. The first 2 numbers here are the length and the width. And the third, that is 3 is for the 3 layers, red, green, and blue. So in our case, they have some other meaning also. Red pixel indicates altitude, blue pixel indicates aspect, and green pixel indicates slope. Okay. So now these are like, so this I am talking about a satellite image. So higher red value means it will be higher in the, it's like mountains. Slope is like which, so if you see if I am, say, let's say, suppose this is a mountain, right? And if somewhere here is a satellite, so I can have a photograph of this also and sometime this also, right? So that's the slope. Okay. And there's something called aspect also, which you can search for Wikipedia.
ऐसे हो गए.
Sorry. Aspect images. Yes.
Search by aspect ratio. Say ratio.
No, ratio is a different. Aspect ratio is a different thing. That's simply the ratio of the length and the breadth, right?
No, width to the height.
Satellite images is there. Not getting the proper link. Aspect, slope, and altitude. Yeah, see this aspect. Okay, it's in geography, yes. Okay. Aspect is the compass direction that the slope faces. For example, a slope on the eastern edge of the Rockies towards the Great Plains is described as having an easterly aspect. A slope which falls down to a deep valley on its western side is a west facing slope. Okay, sorry, this is not the, so this is basically the aspect. So this is one aspect, eastern. If this is east, this will be west. कहाँ से आपका इमेज आ रहा है? Okay.
Yes.
And I believe slope will be the inclination from a surface. Like if there's a surface, what is the inclination from the earth surface? Okay. So now that's my, what is this? Okay, sorry. Yeah. So now the size will give you the size in bytes of the image. That's not required. Now do this minimum. Look at the minimum and the maximum value. So it will give the
By size
minimum. Sorry.
By size we mean the number of pixels in the image, right?
Just a second. Let me check that. If that is true, it should be how much? 37. How much was that? 3725 cross 4797 cross 3, right? Yes, that's the number of pixels, right?
Okay.
I'll simply put it over here. Okay. Now the min and max will give you the minimum and the maximum value. So minimum is 0 and the maximum is 255. So that's the 100% intensity of some particular color in that cell. And 0 means that color is not at all present. Okay. So all the values in my matrix are from 0 to 255 only. Right? Now you can calculate the mean, but it won't make much sense here. If you want, you can calculate like this. Now let's look at the data pixel on the 150th row and 250th column. So I want to look at the pixel of the 150th row and 250th column. So कहाँ पे होगा वो? 150 will be somewhere here and 250 will be also somewhere here. So it should be blue, green, something somewhere here, right? Do this now. You'll see. So it's full intensity in blue. So it will be this only.
And how can we say that this is blue? This is 1735 255.
Yeah.
How do we decode this?
It's RGB.
Oh, okay.
And that the 255 is the maximum value that you have.
So B is for 255.
Is that gone? Just a second. Yeah.
This is blue and
This is mostly, it has some red component also. 1735 green and 255 is blue. So if you want, you can just select.
And D type is going to be constant.
Yeah, yes. If you just copy it, and then you can search for RGB color codings, right? See this. Now I can pass on these values here. So what was my values? 17, 35 and 255, right?
Yes.
Yes.
See this, that's blue. So this is the color there. Okay, I can simply change from here also. Getting it?
Yes.
Okay. So this NumPy is too much used in image processing and image, like if you study deep learning and all, the NumPy is very commonly used. Because we are doing image analysis only, right? So image will be stored like this only. Okay. So now if I do 150, 250, 1, what is the meaning of this? Which color I am printing here?
Green, green component.
We are just
It's
looking at
it's
the
a
green component.
green.
Good. Okay. Now let's do some manipulation now. So it says set a pixel to all zeros. We can set all three layers in a pixel as ones by assigning 0 globally to that row column pairing. But if I just do one pixel to 0, it's not noticeable in the image, right? But let's do it still. So this is not required actually, so I've
One
already
small
wrote.
question.
Sorry,
I have a question on line number 23.
23 here. Okay, tell me.
The output is 35. In the other way, in 22, the output is different. So the
Yes.
input for both looks same.
No, we have not passed the third dimension here. That's why it's giving you all the three values. Now you pass the third
Okay.
dimension. So it's giving you only the second layer, 0, 1, 2, the second layer. So that's green.
Okay, so it is giving us only the intensity of
Green,
green.
exactly. If you want to look at the intensity of red, put a 0. For blue, put a 2. If you put a 3, it will throw an error, index out of bound. Okay,
Okay.
good. Now set pixel at 150, 250 location to 0. So if you plot it again, so you cannot, it's not like you will be able to find that because you just set one pixel to 0. Right? So better will be, we'll pass a line to be 0. Now let's just see this. ये हो गया सबका? Yes, done.
That's done.
Okay,
Yes.
now what we are going to do is we are going to see this. We can also use a range to change the pixel values. As an example, let's set the green layer for rows 200 to 800 to full intensity. Now row value from 200, where is 200? This is 200, right? To 800, I want to make green as 255. Right? Let's do this. So photo underscore data 200 colon 800 will be the rows covered. All the columns means from 0 to 4000 whatever, and only the green color. Make it 255 and then plot it again. You're like, oh shit, why would I read the data again? Yeah. And now see this. So now you have edited an image.
मुझे थोड़ा scroll up करेंगे.
Sure. So all those filters in Snapchat and Instagram are like this only.
Sorry, what did you say, Himanshu?
So all those filters you use in Instagram and Snapchat now for editing an image. So that's all actually in the backend can be like some image processing software only, like Numpy or something. Means you can do is using any language basically. So here we have what we have done. We have set this to green. It's a green filter now, right?
Okay. We have explicitly done that, right?
Yes. Done. Now if you want, you can make it white also, right? So just all the columns should be 255 now. See this. It's 255, 255, 255. That's white.
Himanshu, just one question.
Mhm.
You are just trying to show how it can be done, or is there an objective behind that? I mean, by doing that.
No, the objective is to start playing with NumPy arrays.
Okay.
That's it. So it can be images or it can be any data, right? So the objective is to start learning how we can use NumPy for our job.
So you can read also PDF files also, the NumPy.
PDF files, I don't. It means there should be some separate package for it. Where would you like to okay, so you want to read some image? PDF will be difficult. Image JPG can be easily read. PDF का देखना पड़ेगा.
जो PDF में भी images रहता है, so I just
हाँ तो या तो उसके image को separate कर लो, या फिर I have to see there should be some package that will do for you the import a PDF file.
So R में any, because I am also not sure when R of which package.
R में भी होता होगा, Python में भी होगा कोई. So you can extract text from PDF, rotate PDF pages, merge PDF, split PDF, add watermark to PDF pages. These things you can do using this tutorial. So there's a third-party module called PyPDF2. Okay.
PyPDF is what packets.
PyPDF2. Yeah, I will share this link if you want. Okay, let's come back now. Okay, now do this. Read a fresh file.
One small question, Manju.
Go ahead.
I pinged your code. Actually, I'm trying to put that filter of green. However, I'm getting it completely green.
Completely green means?
Like
like this, right?
It is not something which.
Hello, it
Are
is
you
like this,
able
right?
to see what I pinged?
Yeah, I've seen your codes.
I'm not able to see the screen.
Okay, so your code is similar to what we have
Okay.
done, so it should give a green patch like this only. Not the complete
Um,
image.
so what I am seeing is it's a complete green patch. For you, we are saying it is kind of a layer on top of it, and we can also see what is behind it. But merely it is solid green.
आपने पहले इसको कुछ दूसरे ब्लैक कर दिया था क्या?
मैंने पहले वाइट किया था उसको फिर ग्रीन किया.
हाँ तो इसलिए ना तो सारा 255 हो चुका है. एक सेकेंड, आपने जब पहले वाइट किया था फिर ग्रीन कैसे किया आपने? बाकी दोनों को जीरो किया आपने?
पहले मैंने सिर्फ कोलन के साथ उसको रन किया.
देखो
Let's do it together on your screen.
सब क्या
Without colon. To like if we remove the third colon.
हाँ.
And the question mark, this comma also.
Okay.
And then we do it 255. Now it should be white, right?
Hold on.
Yeah.
That's what I've
so
done.
I
Yeah.
did this thing.
Just hold on. Yes.
Then I added.
So
the
now
one
all
which I
all the
think-
3 layers are 255 only, right? Now if you do this also, I don't think it should still be white only. I'm not sure how you're getting green now. Because all the 3 are already 255. So do one thing.
नहीं वो मैंने फिर उसमें वन पास कर दिया. That is why I'm getting green.
Right. नहीं
So I passed one.
वन से कुछ नहीं होगा जसमीत. अब देखो, अब करो, अब जो कर रहे हो ना, अब अगर आपने ये किया है, अब इसको 255 करोगे ना, now you'll get a green without any what is this L? This is 1. Now see this. So now the R and the blue values are exactly 0. That's why you're not getting anything other than the green. Okay.
So इसके लिए to resolve this, I have to load the image, the
yes. So you
source
lost
image again. And
yes, you lost those values. So yes. Okay, now do this. Read the image again. And now I'm creating a low value filter here. So I want to pick all the pixels with low values. So how I'm defining low values? Any pixel which has values less than 200. Okay. Do this now. So now what we have created is a Boolean mask again. So it's a Boolean array which has only true and false. Now what I want to do is like anytime the low value filter is true, I want to make it 0. Means 0 means black. Okay. Now run this also. See this now. Now compare it with the initial image. You should find some changes here. So all the low intensity should have been 0 now. See this now. That's the actual image, and that's all black, black, black. So now I have only those spots for which the intensity is high.
Can we see the code again?
Sorry. Yes. Do this and then we'll break for 10 minutes.
और लो वैल्यू जो फिल्टर है हमारा उसको हमने डिफाइन किया बाय सेटिंग द पिक्सेल्स
to 0. तो उसको हमने ब्लैक कर दिया पूरा.
and it is in a different code set.
No, we plotted here only. This is the original image and that's the photo underscore data नहीं है, उसको हमने नए किसी ऑब्जेक्ट में नहीं बनाया. Not
So,
saved in any other
like where
variable.
we have defined low value filter.
In the previous cell,
The
okay.
variable low value filter.
Here. Photo underscore data less than 200. Yes, Prabhakar, Samir, Akshay, done?
Yeah,
That's
done.
done.
So now we have, so you got this image like this?
Yes.
Yeah. Yeah.
Okay. So from this, more row and column operations will start after a break. We'll quickly finish this and hopefully we'll start with pandas also. Yes. So we'll meet around 6:30 now. Okay.
Okay. Yeah.
Is everyone back?
I'm there.
Pranali, Prabhakar, Sameer. Pranali is there. Prabhakar and Sameer.
Yes. Yeah, I'm here.
Okay. So now let's do some more rows and column operations. Okay, it says you can design complex patterns by making columns a function of rows and vice versa. Here we try a linear relationship between rows and columns. So now what we are going to do is, let's say I want to create a white line over here. So these are those values for which rows and columns are equal. Okay. So can you tell me how to do that? Let's create a rows underscore range that will have all the values of rows from 0 to the last value. And create columns range that will be rows underscore range. So it's a view of that. Okay. Now for all the values, I just put photo underscore data, rows range and column ranges. Right. So this we did yesterday also, right? So now rows range is a row which has all the row values and column range is equal to this. So now I'm basically doing what I am selecting all the diagonal elements for which rows and columns are same. Getting it? And setting those values to 255. And now you can plot it.
Can you scroll up a little bit?
Sure. Yeah, done.
1 minute. Yes, done.
Okay. Now let's do a masking in the shape of a circular disk. So this image is not loaded. This is on my local file. Just a second. Numpy. Where's my Wi-Fi? Okay, this is what I want to do. I want to do Boolean masking with this circular radius. So any value outside the circle should be true, inside should be false. And then I can do some color settings as per requirement. Right? So let's do this. I'll just upload it on. Where's my console? Console is not there. Yes. Meanwhile, you can start working on it. Okay. Now, how to do this? Any idea? Yes, Pranali. I want to create a circular mask now.
So we will first give the input as radius and center. Then we will find out all the pixels that are forming the circle boundary, and then we will compare whether the pixel values is less than inside and outside. There are two ways. Either we can make use of equation of circle, and if it is less than 0, if it is less than that value, then it is inside, otherwise it is outside. Equal to 0 is means on the circle.
Okay. So how will you define these points? How will you define the boundary?
Radius and center we will take.
Efficient. So center you can calculate from the mean, right?
Yes.
Now let's say I want to create. So now I have rows and columns. So I have less number of rows, more number of columns. Okay, let's say I want to use all the rows. Means this should be touching my boundaries, but there will be some gap left over this side.
Yeah.
Right. So how to calculate the radius? It can simply be number of rows divided by 2, right?
Yeah. Number of columns divided by 2, no?
Yes, sorry, number of columns divided by 2, right? No.
Rows, only rows.
Rows only, yes, because rows are less.
Rows are less.
Okay.
Right. Okay, now see this. So now what we are doing is, first of all, I have separated I've taken the shape and saved into rows, columns, and layers. Right? Now what I'm doing is I'm creating an index, X index and the Y index. Right? अब ये ध्यान से देखना, I'm using a function called np.ogrid. So I'm creating an grid over here. Grid means, now see this. Let's say I have, this is my rows and columns, right? Now I want to save all these values somewhere, and all these values somewhere. Not these values, but these values also. Right? Then only I will be able to subset it, right? Getting it? So I want to create a grid now. So this grid has been created using np.ogrid function. So I'm passing total rows and total columns. So all means it will be 0 to total rows, 0 to total columns. And so now the shape is 3725, 1 and 1, 4795. Do this. One more thing, let's read the help also of ogrid once. See this. It returns an open multidimensional mesh grid. An instance of numpy which returns an open that is not fleshed out mesh grid when indexed, so that only one dimension of each returned array is greater than 1. The dimension and the number of output arrays are equal to the number of indexing dimensions. If the step length is not a complex number, then the stop is not inclusive. It's returning mesh grid with only one dimension. Like this. We'll see the use of it in a moment. So now let's define the centers. Center is simply total rows by 2, total columns by 2. Right? Now I have to create the distance from center, right? Now look at this step. This is a very critical step. Distance from center can be calculated by x minus center row whole square plus y minus center row whole square.
Center column.
Sorry? Center column, right?
Same equation.
Right.
Yeah, x minus x. That equation. We are forming an equation right now.
Right. So now, see, we are calculating the distance of each and every point. Now look, what is x here? X is all the rows, right?
Matrix.
Yes. Y is all the y is all the columns. Now, what will the shape of this x minus center row? Tell me this. It will be center row is a scalar, right? So it will have same shape as x, which is 3725, 1. Right? On the other hand, y minus center will have 1, 4797. Now these are two different shaped matrices. So how am I adding it? Yes.
ब्रॉडकास्टिंग होगा ना
एग्जैक्टली यहाँ ब्रॉडकास्टिंग हो रहा है राइट. तो इसलिए हमने ये पहले ये ग्रिड बनाई थी ऐसे. तो x को हमने एक कॉलम बना, x को एक हमने कॉलम वेक्टर बनाया था, इसको एक रो वेक्टर बनाया था, राइट. Okay. Now, so why is not working? Yes. So now if you see this, this will calculate the distance of all the points. When I say all the points means इन सब का डिस्टेंस भी निकलेगा आपका सेंटर से. तो सर ब्रॉडकास्ट करेंगे, अगर आप एक x की वैल्यू लेते हैं, then y will change, right? So it's like, let me give you a small example. Let's take a value like this. Now I have 1, 2, 3. Okay, and then we have 1, 2, 3, 4. Right, it's 3 comma 1, it's 1 comma 4. And then I have to, let's say, add it. Right? So how will I add it? I will make it 4 times. And I'll make it
3 times.
3 times. So now each value will be added to this, right? Means तो जब हम इसको replicate कर रहे हैं तो ये automatically इसके अंदर move करेगा, right? है ना? And columns ऐसे move करेंगे अब, तो सारे points आपके cover हो जाएंगे अंदर वाले. So if I have a point 100, 100, वो भी आपका आएगा ही आएगा हमेशा इसमें. If I do this. Okay?
Himanshu, would it be possible for you to just reiterate the process briefly? मुझे थोड़ा समझ आया. I was disconnected for during this while.
See. So what I'm doing is I found the center here. Okay. So for example, this is my figure. Now I want to cut a circle.
Found the center by
I want to cut
taking
a
the
circle
mean
like
of
this,
the
right?
rows.
Yes.
Yes.
So now I want to find out the distance of each point from my center.
Yes.
And if they're more than my radius, they will be outside. Otherwise, they will be inside. Right. So now I'm trying to find out the distance of each and every pixel from my center.
Okay.
And the distance formula is, you know, that x minus x naught whole square plus y minus y naught whole square.
Yep.
Right. So now my x is a vector, y is a separate vector. X is my row index, y is my column index. Okay. So now this is my 37 something something. How much is that? 3725 comma 1, and y is my 1 comma 4797. And now when I add the two, they will be a 3725 cross 4797 matrix by broadcasting. And then I will have distance of each and every pixel from the center.
Okay. And then we'll apply the filter on that.
Yeah, so now this is distance from center, right? Now we'll create a filter. So that's my circular mask. So what is the radius here? Radius is total rows by 2 square. Because here I've taken I've not taken the square root, so I'm just doing first square of distance only. इसलिए radius का भी मैंने यहाँ पे square कर दिया. Right? And now this is my circular mask, which is ready here. Okay. Now what I'm doing, any value which is, so for me outside value is true, inside value is false. So any value which is true is black. So इसको पूरा black कर दूंगा मैं. And this is how my image will look like.
Okay.
So all outside values are black.
Yes. See
That's
this?
right.
Yes. Oh, sorry, I have to read the image again. See this now.
सर कोड दिखा दीजिए।
एक सेकेंड,
हाँ दिखाइए।
ये वाला।
हाँ मतलब आई वॉज जस्ट अंडरस्टैंडिंग इट, तो मैंने लिखा ही नहीं।
ओके, yes, how about others done this?
No, it's fine. Just 2 minutes, Himanshu.
Sure.
थोड़ा कोड दिखाइए।
हुआ ये? So you calculate the center, you calculate the distance, and then now this line is the most trickiest. If you can do this, then it's pretty easy.
Yes.
Done?
There's a code below this as well.
Yeah. That's for changing the color, that's it.
Done.
Okay, good. Now let's do one more thing here. So this you do yourself. Okay. Now what I want to do is like I just want to have a upper half disk, not the lower half. Right, means I want to make the lower half all black. Let me just check. Okay. Now let's see this now. So again I will create an NP grid. Okay. So the upper half will have x less than center row. So this start from 0, right? So upper half will be up to half of it. Half of the center, right? And the lower half will be more than that, right? So now what I'm doing is I'm creating a half upper mask. Okay. I'm using a logical AND. What is the meaning of logical AND? Means both conditions should be true simultaneously. if the x value is less than center row and if the circular mask is also true, right, then I will put it as in the half upper mask, right, means these values, the upper values, bahar wale, these ones, outside one will be true for that circular mask, right? And now I want to make sure that this is only up the upper half only. Okay, now let's do this, and now this is my new mask. Now let's see how to do this. क्या error आ गया? See this now. So then the lower thing is as it is, the upper thing has been masked half. Okay, so for this we have used this np.logical end. There are other functions also like this. Logical not, logical or, logical XOR and all. Okay. Done this. आप लोग असाइनमेंट करना इस वीक है ना, नंपाई का असाइनमेंट भी डाल दूंगा मैं मूडल पे, वो भी कर लेना, ठीक है? और इसको प्रैक्टिस करना एक बार फिर से, इस केस को.
So numpy में वो logical and ऐसे ही मीन just logical underscore and we are using this operator.
हाँ, ऐसे भी कर सकते हो, वैसे भी यूज कर सकते हो, एंड साइन से भी.
And so
Okay. Now do this. I want to. It says that the red pixels show me the altitude of that place, height of that place, right? So I want you to highlight all the high altitude areas only. So we'll do this by detecting high intensity red pixels and muting down other areas. So now create a Boolean mask which only shows you the high altitude regions. So जिसकी value left 150 और red की, उसको हम मास्क कर देंगे, बाकी अदर देन दैट वी विल शो। ये खुद से करो। In the original image, I just want to show only those pixels which have a red value more than 150. Others should be all marked as black. So create a mask. Okay. Red mask which has all the values less than 150. And then filter your data with 0 and make it, and then print the image. Now look at this. So these are all your high altitude regions. हुआ ये? Same thing I can do for high green regions also, which I'm not doing, and same thing for high blue also. So that's your high green regions, and that's your, ये भी execute हो रहा है.
Yeah.
This your blue region, right? And now I want you to mask all the three together. Create a composite mask that takes thresholds on all the three layers, red, green and blue. Less than 150 for red, more than 100 for green and less than 100 for blue. Let's make it all high density, high intensity only. So 150, let's make it. Okay, so these are your high pixel values.
One question, आपने red में इसे condition दे 150 but green and blue में 100. So is there any justification for this?
No justification, like अगर ये 150 कर दोगे तो आपको बचेगी नहीं ज़्यादा वैल्यूज. बहुत ज़्यादा हाई इंटेंसिटी ब्लू है नहीं इसमें. If I make it 150, so you'll get very less images. Means mostly आपका 0 हो जाएगा. So now I have only those values for which we have intensities more than 150 for all of them, right? तो आपका ब्लू तो ऑलमोस्ट चला ही गया, रेड और ग्रीन दिख रहे हैं बस. Can you see this?
Yeah.
इसलिए इसको थोड़ा थ्रेशोल्ड अपने हिसाब से चेंज कर सकते हो. अगर ब्लू ज़्यादा चाहिए तो मास्क थोड़ा कम लगा दो. Okay. Finish this and we will start with the next topic. Yep, done.
Yes.
Done. Yes.
Okay. So that's it for NumPy now. Okay. इसका एक असाइनमेंट है, वो भी कर लीजिएगा तो आपको और प्रैक्टिस हो जाएगा. Okay. Now we have to start with pandas. Okay. Now what I request you